Good morning, everybody. My name is John Capone. I'm the Western Regional Sales Manager for ICM. Also on the call today, you've already heard Paige Hart in our marketing department. And also on the call is a gentleman by the name of John Finetti. John works in our engineering and technical services department. So if you call in or have customers call in on questions for ICM from a technical aspect, there's a good chance they'll be talking to Mr. Finetti. Why is ICM doing this product? At the end of the day, we're seeing far more heat pumps come into markets that traditionally were gas furnaces and straight cool. But the advent of electrification in a lot of states, and a lot of markets across the United States, kind of backed with rebates, you're seeing more heat pumps go into markets that traditionally they didn't exist. Part of the byproduct, of course, of using a heat pump is it has a tendency to have some obstacles when it's in a cold climate as far as heat buildup on the outdoor coil. So it needs a defrost mechanism to be able to, defrost the coil so that it can operate as efficiently as it needs to. Once again, the defrost boards prevent ice buildup on the outdoor coil, and it allows it to run much more efficiently at the temperatures. Traditionally, early on, heat pumps weren't used in cold markets, but as the manufacturers have come up with better technology, these heat pumps can get to lower temperatures and keep their efficiencies than ever before. Once again, the defrost board will prevent a lot of damage to the coil. It's going to extend the life of the equipment, and it's going to prevent a lot of nuisance or service callbacks. What happens when a defrost goes into a heat pump goes into defrost? The system detects frost buildup when the outdoor temperature drops below 32 degrees. The reversing valve is going to switch into cooling mode. So if you're all familiar with going into cooling mode, you're going to have a hot liquid at high pressure refrigerant go through your outdoor coil or condensing unit, and that's what's going to do the defrost. The outdoor unit's going to stop running the fan, so it's not pulling that hot air out of the outdoor coil, so that it can really focus all that heat just on defrosting the coils on the outside and the fins. In real cold climates, as a general rule, on a heat pump, you're going to see heat strips or some auxiliary heat source. And so those will generally kick in when it goes into defrost mode. This all happens when the ICM board gets installed. So let's talk about that a little bit more. The ICM-UDefrost board. So with the high cost of OEM boards, and you're getting more limited access to those parts, having an aftermarket company provide this is really going to help out. So our singular universal defrost board replaces the function of nearly all traditional time and temperature heat pumps on the market today. When you order one, what will come in, of course, is the board itself, and you're going to get two different thermistor sensors, which we'll cover here in another slide or so. The universal defrost board is a time and temperature terminate defrost board. It uses NFC, near field communications, to actually go ahead and set the parameters and program the device. It time and temperature terminate defrost. It has anti-short cycle, quiet shift, and unit staging delays. It has a high temp auxiliary heat lockout, a low temp compressor lockout. Once you install it, it has a field test speed up mode. It has brownout protection. It has diagnostic LED indicators to help you in troubleshooting. It's got a thermostat style coil and outdoor air temperature sensors as well. And you'll see those to the bottom right, and we'll cover those deeper in a slide upcoming. Here's the slide, or here's the sensors you're going to see. So the outdoor coil temperature sensor is the one in the upper right. This is designed to measure the outdoor coil temperature, which is used by the defrost board to enter and exit the defrost cycle. So this is going to actually attach somewhere inside to a coil or a fin, because what it's trying to do is register the temperature of that so it knows where your 32 degrees is, so you can go into defrost mode. You're also going to have in it the ambient thermistor. It measures the ambient or the outside air. Be very cautious when installing this that it's not too close to the coil temperature sensor, or it's not touching or very close to anything that's metal, because what it'll do is it could skew the actual temperature of the ambient air. The field test mode. The test button, you can see if you go directly kind of down to the middle where the little box is on there, that's where it's actually the test mode is. So once it's actually installed and you have power going to this, you can actually hit that test mode. But the real thing that's real important to this is you can't just test it if it's 50 degrees or 40 degrees outside. It needs to be at the normal conditions that the defrost mode will go into. Here's some diagnostics and troubleshooting. I won't go through all of these, but one of the important things to remember is if you look at right below the diagnostics header, you'll see display, cool LED, heat LED, the status LED. Remember those, because what it is when we go to this slide here, right down on the bottom of the board, you'll see status, heat, and cool. Those lights will either be on or off, or they'll be blinking, and that will associate back to that chart on what the fault code is. So it makes it very simple for everybody to see what the potential problem is and what the fix is. So NFC technology. So one of the things you're going to have to do on this product is you're going to have to download from either the Apple Store or Google Play the ICM Omni app. On this app is how you're going to be able to program this device. And the real neat thing about it is you can actually pre-program it for your truck, so you're not out in 30, 20 degree weather. And you can actually, once it's programmed, is when you can actually do your install, and then you can upload the program into the product. It's a pretty neat feature. Step one is you open up the app and you select program device. The middle picture in there is exactly what you're going to see on your phone. So you're going to scroll down to the defrost, and then you're going to click on it, create new program. The image to your left is what's going to appear. Now, these already come up with presets from the factory. So if you choose not to, you can leave it exactly as is. But if you want to make certain modifications, you're more than welcome to using this app. Mr. Finetti, would you like to go through some of these basic user settings?
Absolutely. The nice thing about this is it's a universal control, right? So a lot of your aftermarket defrost boards, or even a lot of your OEM defrost boards, they're going to have a lot of the similar features that we have here. So a lot of your boards will come with some type of anti-short cycle delay to protect your compressor from short cycling and when it's going in and out of different modes. Okay, so we always have that available for you to set. The nice thing about this is it also has a staging delay, so you can stage if you have multiple units. You could stage the delay between turn-on times of those units. It's a delay on make timer in a sense. So if you have more than one stage, you could stage the delay time between turn-on times of the compressors. You also have reversing valve configurations. So we all know that Rheem likes to use heat active. Everything is heat active with Rheem. So for example, then we could say, okay, let's set our reversing valve to energize and heating rather than cooling. So a lot of your equipment uses cool active reversing valve. That just means that the reversing valve that switches the refrigerant flow is active during the cooling cycle. And then, but there are some boards that are different. So we give you that option, again, that universal feature. The defrost enable temperature. This is the temperature that you would set to enable defrost. So not every particular board is going to be exactly the same. You might want to enter defrost a little later than 32 degrees. You might want to say, I want to get down to 27 before I enter defrost, because my area, I'm not going to develop frost until it gets a little bit colder. So, all of those things are user settable here. And you can also set the defrost end temperature. Let's say you want the defrost to exit defrost at a temperature of above 55 degrees. You could set it to that. And remember that this is a time and temperature or temperature terminate, right? So you can set now that as well. So you can set your defrost time as well. And we'll get down to that in a few more steps here. But your defrost interval timer is the time that you're going to give it between defrost cycles. So let's say you're in a warmer climate out west, you won't need an hour between defrosts. You won't need only 30 minutes between defrosts. You might want an hour between defrost cycles, or maybe 90 minutes. So you can set that based on the climate that you're in. So that's the interval between the defrost cycles. And here we are with that maximum defrost time, because I was mentioning it could be time or temperature terminated. So we set the temperature termination, but we also can set the maximum defrost time. Let's say you want it more than 10 minutes. Maybe you want it 15 minutes, or maybe you don't want it 10 minutes. Maybe you only want a 7-minute defrost, depending on your climate. Again, all user settable features to match different OEM specifications or different aftermarket products. There's also a quiet shift. But what is this? This is when, if anybody's ever dealt with the heat pumps, when the reversing valve dumps, you get that big bang, and if your heat pump is right near your bedroom or something in the middle of the night, you don't want to hear that thing banging and waking you out of your sleep. So this quiet shift allows the unit to, it keeps the reversing valve energized until the Y call is ended, and after the Y call is ended for a little period of time to allow the refrigerant to stabilize in the system, and then it drops the reversing valve when it's not under pressure, and that makes a much quieter shift.
In quiet shift, John, does it actually activate the fan?
No, the fan will be just running as the normal cycle, because you'll be out of defrost essentially, and it'll be running as the normal cycle. You're just keeping that reversing valve energized until the end of the Y call and a little bit beyond the Y call, so that you allow the the system pressure to stabilize, so that when it does shift, it's not shifting under pressure and making that awful loud noise. You also can do high pressure monitoring and low pressure monitoring, but you have to enable those features, because not every defrost has the ability to measure high and low pressure sensors. So if you don't have that feature on your original equipment, you can choose to leave it disabled, or if your original defrost board had those features, now you can enable them here in our defrost board. So we give you the option to have it either way. Again, that universal function. We also have a nice lockout feature for the compressor lockout in low ambient conditions. So let's say you don't want your heat pump to run in heat pump mode when it's like 15 degrees outside. At that point, even with these cold climate heat pumps, they get to a point where the thermal transfer is just not there. And it's kind of a waste of energy to just run it when it's not really helping anything. You're going to be running mostly your auxiliary heat anyway. So you can enable a lockout. All right. And so you enable it first, and then you go in and you set the lockout temperature with the compressor contactor lockout temp. And say you say, okay, I don't want this thing to even, run in temperatures below 15 degrees. I want to just be on my auxiliary heat. And so you can do that based on that temperature that you set. Now, likewise, you could go the other way and say, okay, I don't want this to lock out when it's, at a time when I could be using the heat pump. So, so let's say you want to keep this from going into this lockout. Say, hey, electricity costs a lot of money. My electric heat strips are going to, use up a lot of electrical energy. So I don't want this really to come out unless it's absolutely necessary. So you might want to say, okay, hey, at temperatures above 35 degrees, I don't ever want to go into heat pump lockout. I don't want to use my emergency strips unless I'm down at 15 degrees. I don't. So you can go both ways, right? So you can lock it out to not go into the auxiliary heat at a higher temperature. So you enable it and then set that higher temperature with the auxiliary lockout temperature. So these are all these nice user settable features which cover, I would say, 99% of the things you're going to see in most of your defrost boards. Now, I will tell you, there will be some things like condensate sensors and some specific OEM freeze protection. You might have some things like that that are built into some of these real fancy OEM boards. It may not cover all of those things, but you'll get the basic defrost functionality, and even more than just basic. You'll get a very well-rounded defrost application for 90% of all of your defrost, um, applications you need to cover. Okay, John, back to you.
Thank you, sir. And once again, we talk about our NFC technology. This is one of the things that you really is kind of critical for everybody, because this is a great product to have in everybody's truck in some of those markets. So they're not having to go out, view a heat pump, ascertain what it is, and then they have to drive back and forth through the distributor to pick it up. It's a great product to have as a common truck stop. But one of the things that would be super helpful to have everybody have at the counters, if you're a distributor or if you're a contractor, to have a copy of this, is all the different boards that it's going to replace. So if we add up basically all the old ICM boards and a lot of the current OEM products that we carry, it's probably between 275 and over 300 different products that it ideally covers. So it's a tremendous product as a universal to have on your truck to save a contractor time and money driving back and forth, just trying to pick something up. He could easily just have it in his truck and he can take care of the service call right then and there. You can get this from our website. If you're a distributor, you can ask your representative to print you one out or send you the file on it so that you can have it and distribute it to all of your people as well. So it's a great product to have in the trucks. Once again, on our website, you can go ahead and print out and download cell sheets, installation instruction, wiring diagrams. You'll see on the very bottom of most of these documents, you'll have a 1-800 number. So you can actually call and talk to somebody like Mr. Finetti that was just speaking a while ago, can answer any of your questions, take care of any technical obstacles you might have, any deeper things as far as programming. He can answer those for you. You can get those at www.icmcontrols.com. I highly recommend, if you don't have this documentation, that you download it and you have it accessible for you, because it'll really help you answer some basic questions. And in the field, if you're a distributor and a sales rep visiting with a contractor, I highly recommend that you push them to download 2 apps. The one that we talked about was the ICM Omni app, so that you can do your programming. The other app is a general app that we have that you can do cross-referencing on, and you also have the opportunity to see these documents on your phone directly from that app as well. So those are 2 good apps to be able to download and have on your phone that'll be very useful to your folks in the field. Well, any questions do we have, Paige?
No questions in the chat yet, but the floor is open. So if anyone does have any questions for John K or John F, please feel free to ask them now.
While we're at it, waiting for some questions, I'll just reiterate the what John has covered already. The importance of a universal control. I've gotten a lot of calls where people had some of the older products like the ICM 300 or the 302 or some of the other ones that we used to have. And this product, keep in mind, will replace all of those defrost boards that we used to carry aftermarket. Plus, many of the OEMs will be able to be replaced by this board. The near field communication uh, is very handy because, like John had said, hey, it's cold outside or something. You don't want to be sitting out there in the cold. You can program the entire board. You can have the board, the defrost board in your hand, program the entire thing exactly the way you want it. And all you got to do is run out there, plug the wires in and go, run the test mode if you'd like. And what that does is, again, it reduces all of the timing cycles down to a point where, they're very short, only seconds rather than they would be minutes. And you can kind of see what it's doing. And if the board is working, and then everything is working, you can be in and out of the job site quickly. And so that's the convenience of near field communication. In near field communication uses an antenna that's in your phone and the antenna that's on the board, and it just uses the battery that's in your phone to, basically induce the signal into our board. And so all of that's done wirelessly and can be done in your truck. You don't need access to the internet. None of that's important. It's all done through your phone with everything that you have right there available to you.
Hey, John, oftentimes I get a question in the field when I'm talking about near field communications because, we've got the head pressure control and a couple of timers that are also near field. How close do you want to get that to the actual product to ensure that the programming transfers?
That's a good question. And also I want to bring to your attention, you don't want any power to the board. You don't want to really do these when they're powered up because when power is running, electricity is running through wires, they create an electromagnetic field around the wires. And that electromagnetic field that's generated around the wires will interfere with our near field communication process. So it's better to always program when you're not powered. And as far as to answer the question that John had proposed, you want that as close as possible, the antenna of your phone to be as close as possible to the board, if not actually touching the antenna on our board. There's a little circle with an N around it on our board, and you could just literally be within a 1/16 of an inch, or I just touch the board with like if it's an iPhone, I touch the board with the tip of the iPhone, and that does the job. If it's a Android, your antenna is more closer to the center of the phone, so you kind of hover over as close as you possibly can. So be very, very close because remember, you're using just the battery power in your phone that's energizing the antenna to send that signal out. So there's not a whole lot of power there, so you got to be real close. You got to be real close. Good question. Are there any other questions that anybody has about either the technology or what this board is capable of, or any of the settings we talked about? Does that all make sense to everybody? Hopefully. Sounds like it might. So thank you all for joining us. Again, if you have any other questions beyond this that you think of later, you're more than welcome to call me at the 1-800 number. So it's 1-800-365-5525. And there'll be this webinar will also be available on our website. And we'll be here to answer any questions.
Thank you, everyone.